Okay, for number 5, it says consider the set of all solutions x, y for this equation over here. By the way, there's an infinite number of solutions to that problem, right? But it goes on to say where x and y are integers. It says, what is the sum of all values of y occurring in such pairs? I'm going to go to the whiteboard, make some attempt to solve this problem. And the way to do it is I'm going to kind of visualize it first. So what do you see? It's number 5. 5 is, let's see, 3x squared is equal to 3y to the 4th power plus 2013. All right, the first thing I'd like to do is just kind of visualize it. And it almost reminds me of like, a hyperbola, but it's not. I'm not saying it is. But 3x squared minus 3y4 equals 2013. And what I'm going to do is I'm going to divide both sides by 3, and you get x squared. Makes it easier for me, by the way. Minus y4, and 3 into 2013. By the way, I know it's by 3 because I'm looking at the sum of the digits. 3 and 1 is 4, and 4 and 2 is 6, and 6 is by 3, so this can be divided by 3. You get 6, that gives you 18, 21, and that's going to give you 7, and that's going to give you 1. So 6, 7, 1. All right? I want to kind of visualize this thing. And one thing I know about this, just looking at it, it's got a lot of symmetry. So I'm going to say it's even symmetry. And how do I know that? If you replace x by minus x, there's no change in equation. It's also going to be odd symmetry. How do I know that? If you replace x by minus x and y by minus y, there's no change in it. It also has x-axis symmetry. Again, if you replace y by minus y, there's no change. So it's got a lot of symmetry. So what I want to do is I want to just maybe write a little differently and kind of visualize this before I go on the wild goose chase to find the integers. All right? Well, kind of looking at this, I could say x is equal to plus or minus. And I'm looking at this thing over here, and I'm starting to realize that symmetry helps me a little bit. I'm going to say that you get rid of the y, just set it equal to 0. And you get the root of 671, plus or minus. Again, I know it's symmetric. All right? All right, this is the square root of 671. This is minus the root of 671. I know it has x-axis symmetry. I know it has y-axis symmetry and origin symmetry. So I can do something like this over here. And again, I'm not saying it's terribly accurate. All right. I'm also going to claim it's asymptotic. And if I thought about that, what I'm saying is if when x, whoops, sorry about that. When x and y are going off to plus or minus infinity, that these two things are essentially equal. I mean, I know they differ by 671, but when you're getting huge, a difference of 671 doesn't really matter much. So what would you get over there? You would get, x equals plus or minus that, which I'm going to say these things are asymptotic with parabolas. I go like this over here. Now that's not telling me what the integers are, but it tells me visually I'm getting something over here. So what I want to do is I want to take a look at this and talk about integer values. And the way I would probably do this is try to factor the problem. So what do I know is I know that 671, I'm hoping it factors, and I'm looking at this over here. I want to think about it. And I'm looking for numbers that go into that. And certainly I'm looking for prime numbers. And so I'm going to say definitely not 2. 3 is out of the question. 4 is out of the question. 5 is out of the question. I think 11. Let me see if it's 11 now. Yeah, look at that. 11 times 61. By the way, both 11 and 61 are prime. I can't go further than that. Erase this over here. I want to factor the other side, though, and I'm hoping it's going to be easy to do. So you can get x minus y squared, and then you're going to get x plus y squared. By the way, the picture is going to help me a great deal, by the way, because I know if I find an integer here, I'd find an integer there, find an integer there, get one over there. I'm kind of thinking that, I'm not sure what it's going to be, but I'm going to put this down now. I'm going to say x minus y squared is equal to 11. And if I said that, then x plus y squared would have to be 61. Let me see if I get an integer there, though. I'm going to add those two together. And you get 2x equals, well, 61, the y squares disappear, by the way, is going to be 72. And I do get an integer. What integer do I get? I get 36. So right now I'm going to say the x is 36. So I'm going to say over here, let's put this over, 36. 36. And by the pictures help me a little bit. I want to know what the y is going to be, though. And so I'll use this equation over here. So 36 minus y squared. I don't know if it's going to be integer. I'll figure out maybe there's no integer. So what do you get over here? 36 minus 11 equals y squared. 36 minus 11 is 25 equals y squared. Yeah, plus or minus 5. By the way, that symmetry helps me a great deal, by the way. And I'll tell you why. Over here, I know the answer over here now. What's it going to be? Minus 36 minus 5. What's this point over here going to be? Minus 36, 5. And again, that even, odd x-axis image really helped me out a great deal there. So I got 4 points. 4 points. So yeah, I go back and read the question now. And the question is, consider the set of all solutions. Oh, by the way, if you want, you can do this over here. X minus y squared is 61, and x plus y squared is equal to 11. And you get 2x, and 61 and 11 is going to be 72, and you still get 36, by the way. All right? It's really not helped me out a great deal there. So I got my picture helped me out a great deal. So I want to go back and read the question. Consider the set of all solutions over here. I found 4 integer pair solutions. Let me just outline that for you. They're right here. And what did they ask me to do? What's the sum of all the y's occurring? Looks like 0. And why is that? If you look at it, you get 5, minus 5, 5, and minus 5. If you add those together, you get 0. And we're done. Thank you.